In this video, we're going to demonstrate how you can audit an image in the Western Blot Utility. The intent is hopefully like the name sounds. The idea is that the audit image functionality gives the user full insight into the calculations going on behind the scenes. So we're trying to empower users to double check and verify what values we're producing. So the way you do that is you go to File and Audit Image. So here a dialog will be opened, and it just takes the image name and adds Audit at the end of it. And so I'm going to save that to my desktop. And then we're going to go ahead and open that CSV. Okay. So I'm going to do a little bit of formatting just to make things a little bit easier. So our columns, we're going to give it a width of 1.5. And you can open that CSV obviously in Excel. I'm just using Linux, so I'm using LibreOffice. And I'm doing a few things to just make it a little bit easier to interpret. So in our image, we had 5 lanes, right? We can confirm that. So 1, 2, 3, 4, 5. And then here we can see we have a header, just describe a quick description of what the value is. And then we made an effort to go into detail about the value in each column in this description here. But basically you can see here, it breaks it down by lane. It tells you what the background value was, the total background subtracted, the pixel count, the raw summed intensity, the adjusted sum intensity, the mean values, and then it gets into our normalization. So in this case, I'm sure you noticed we didn't have any normalization factors. So you'll find that those fields are empty. And then lastly, it has the raw positioning of the ROI and then the method that is used for background detection. So now we're going to go back in and do some normalization. So here I have the AMP cab and the control for it. So I am going to make sure that all the lanes are appropriately labeled. And yep, everything looks good. So now I'm going to assign my loading control. So here we got exactly one match for our loading control. And so you'll see our normalization has started. And so this is using the loading factor. And then I'm going to additionally select lane 1 as my control, right? You can select whatever lanes you want. You can do multiple. You can see the values change as we do that. But since we're trying to demonstrate the audit image, I'm going to go in and I'm going to audit these calculations. So once again, I will save this file. And you can see that the file name matches the image and adds the audit suffix. So once again, I'm just going to do a little bit of cleanup to make this a little bit easier to read. So the exact same values that you saw, or not the exact same values, the exact same column types that you saw in the previous spreadsheet are here. So in this case, we have 9 lanes, and we should confirm that, right? We have, yep, 9 lanes. So for each lane, we break it down. Once again, the background, the raw summed intensity, the mean intensity, and then here we get into normalization, starting at column I. So our loading control factor, we have a link in here to the Thermo Fisher documentation that we reference, and you can see the factors that are calculated per lane based on the loading control. And then here we actually apply that factor in isolation to the loading control, or from the loading control factor to our experimental values. And this is the normalized values for our image. It's not accounting for the internal control factors yet. Then here we calculate our internal control factors, which once again is just taken by dividing the experimental intensity by the internal control intensity. And so there could be multiple. So in this case, we demonstrate the array or the list of values. In this case, there's only one. And then we show the combined factor, which is the averaged value. And then we communicate the resulting calculation in terms of the intensity values normalized to the internal control. And in this case, we fortunately have both a loading control normalization factor and internal control. So these columns get into the factor we use for normalization in that case, which is basically the same as the internal control factor, except for that factor is now normalized to the loading control, and specifically the lane associated with the internal control. And that gets us the ultimate adjusted internal control factors that we then use to normalize the intensity. And so here you can see the final normalized intensity of this image when you account for both the loading control and the internal control. So everything should be here to empower you to go through and reproduce these calculations. You could probably take this exact spreadsheet, add some formulas, and produce the same results. And that's a wrap for the audit functionality.